Hello, everybody. Welcome back to 8th grade math. Today we are learning about the Pythagorean theorem and just going to start off with kind of looking at what is a right triangle, although we probably have a good idea at this point, but being very specific about labeling because labeling is going to be very important today. Now, in a right triangle, the two sides adjacent to the right angle are known as the legs, or A and B. So adjacent meaning that they are touching that right angle. So this right here will be a leg, and this side will be a leg. Now, it doesn't really matter which one you label as A and which one is B. I mean, if you want to get very picky, I usually like to put A as the shortest side, but it really doesn't matter. What really matters is the third side, which is C. And let's talk about that. The side opposite from the right angle is called the hypotenuse, or side C. So here is our hypotenuse. I'm going to abbreviate that and label that as side C. So here in a second, we're going to practice finding our hypotenuse. But I'm going to show you guys kind of a little trick that helps me find it. What I do is I find my right angle, which is usually marked by this little box, and I look at where it points. It will always point to your hypotenuse. So just a little trick there. We're going to practice that here in a few minutes. It says the hypotenuse is always the longest side of a right triangle. And obviously, if you look here, this is definitely longer than these two sides. Now, the Pythagorean theorem tells us how the side lengths of right triangles are related. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. More simply stated, we can use this formula. So, very simple to use. A squared plus B squared equals C squared. Obviously, it's something we're going to have to memorize, but not too hard, right? A, B, C, they all got squares on them. Now, like I said a second ago, I talked about how sometimes you're going to have to find which one's C because C is the most important. A and B could be either side that we just label here. Now, to find this, like I said, we're going to use that little trick I showed you guys by finding that corner of your right angle box and knowing that it is always going to point to your hypotenuse. And we're going to label the hypotenuse as C. So, drew a little arrow here, side C, and that can be A, that can be B. What you're going to do right now is you are going to quietly attempt to find the hypotenuse of each of these three sides. I'm going to give you guys about 30 seconds of quiet work time and then a minute to compare and discuss with your group. So go ahead and start that now. Okay, after some discussion with our groups, go ahead, let's look back up to the board and you're going to compare yours with mine. Now, your A and B may be different. They may be flip-flopped, and that's perfectly fine as long as your C matches mine. So you can say, I took the corner of that, drew a little arrow, found C. Drew a little arrow, found C. Drew a little arrow, found C. So accurately and quickly found the hypotenuse for each of these. Now, it says use the Pythagorean theorem to find the missing side length in each triangle, round to the nearest tenth if necessary. So in this first section of our notes, what we're going to do is look at specifically finding the hypotenuse, because if we look here, this is definitely our right angle, and it's going to point here to our hypotenuse, C. And using that very easy to remember, A squared plus B squared equals C squared, I'm going to fill in what I know. Now, I don't know what C is. I've labeled that. There's no measurement there, but we can say this is A and this is B. And we can substitute those values that we already know in. So, my camera focus, we're saying A is 3 inches. So, in place of A, I'm going to substitute in 3. In place of B, I'm going to substitute in 4. And then we have C squared. Now, 3 squared, we should know is 3 times 3. 4 squared is 4 times 4. Very simple to do in your head. But if you didn't know how to do that, you would, of course, pop over here, use your Desmos calculator, and do the number times itself. Or if you look over to the top left of this section, it has a little square button. So very, very simple. Now, 3 squared plus 4 squared. 3 squared is 9. 4 times 4 is 16. So we have 9 plus 16 equals C squared. And then 16 plus 9, doing this little chunk right here, is 25 equals C squared. So this is a little different than equations we've done in the past because we've just had just the variable. In this case, we have a variable that's squared. So if I'm trying to get the variable by itself, I've got to get rid of that squared. And the only way to undo squaring something is to, let's think about that and go ahead right now and discuss with your group, how would we undo squaring something? And I'll call you guys back in about 45 seconds and we'll discuss this as a class. Okay? So after discussing as a class, we've determined that the best way to, well, the only way to undo squaring something is to take the square root. So technically, we're taking the square root of both sides and getting this to be just C, because the square root of a square would be just itself. And taking the square root of 25, I'm saying what times itself gives me 25? Oh, 5 times 5. So the square root of 25 is 5. But if you didn't know what the square root of 25 was, because there are going to be some numbers that we deal with that are quite large, there's a square root button here in Desmos that will help us out. 25, the square root of 25 is 5. So there we have it. Our third side length is 5. Now looking at this once again, a little bit more of a complex one because we do have a larger number here. I am finding my right angle and looking directly across to know that this must be C, so this must be A and B. What we're going to do now is substitute that into the equation, and I'm going to give you a second to attempt that on your own. Go ahead and do that now. Okay. So you should have written 24 squared plus 7 squared equals C squared. Go ahead and see how far you can take that problem. Okay, so 24 squared is 24 times 24. You should have got 576. 7 times 7 is 49 equals C squared. 579 plus 49, I don't know about you, but I would have had to type that in the calculator. 625 equals C squared. And then we're going to have to take the square root. So everyone right now on your calculators, go ahead and take the square root of 625. Oh, square root of 625 is 25. So our hypotenuse is 25 centimeters. Now, this last one, you're going to attempt entirely on your own. Go ahead, try it out, and I'm going to give you guys about a minute of silent work time. Then we're going to share with our group for about another minute and be sure we all know what we're doing here. So go ahead, start your silent work time now. Okay, so after discussing with our group, go ahead and start looking at mine. And I'm going to kind of give a little explanation of what I just did here. Hopefully you have done the same. If not, pay very close attention to what I've done so you can correct any of your mistakes. Now, I plugged in, well, first of all, I found that this was C by looking at my 90-degree angle and going directly across from it. So I know that either of these could be A or B. I'm just going to say 12 is A. 12 squared plus 7 squared. 12 squared is 144. 7 squared is 149. And then I got 193 as my answer there. So of course, we're going to take the square root of 193. And the problem with that is that the 193 is not a perfect square. We have 13.89. In this case, what I want you guys to do, this says to round to the nearest tenth. I just want you to follow that. That 9 is going to bump that 8 up, and then that's going to bump that up to a 14. So we're going to say it is about 14. Now, going to look at finding the missing side length using the Pythagorean theorem, and just getting a little glimpse on this. This is a little different because it has already given us C. We are going to have to find one of the missing legs. So we have A, B, C. B is the one that's missing, and just the way I labeled it. But it wouldn't matter. It would work out the same even if you said this was B. So when I'm rewriting this now, I'm going to have 5 squared plus B squared, because I don't know what B is, equals 13 squared. Now, 5 times 5 is 25. Don't know what B squared is, so I'm just going to bring that down. 13 squared is 169. And now I'm going to have to kind of balance this out like we would a regular equation where we do our inverse operations. So trying to get B by itself, I'm going to subtract 25 from both sides. B squared equals 169 minus 25 is 144. Then have to take the square root of both sides. So taking the square root of B, B squared, and taking the square root of 144, B is 12. So our missing side length is 12 inches. So with this next one, going to look right here for our right angle and label the hypotenuse because that one is the most important one. A and B are interchangeable. So going to say this is A, this is B. This time I'm going to look for A. Don't know what A is. I'm going to write A squared plus, we do know what B is. 6 squared equals 10 squared. Go ahead and see if you can solve this the rest of the way out. And going to give about 30 seconds of quiet time and then about a minute of discuss and fix time. Go ahead, get started on that. Okay, attention back on the board. Go ahead and check yours with mine. What I've done here is I, of course, substituted in what I knew. 6 times 6 is 36. 10 times 10 is 100. I subtracted 36 from both sides to try to get A isolated. Then I took the square root of both sides to get 8. So we're going to save the word problems for tomorrow. We're going to come back to those. Today we're just going to be practicing finding the missing side lengths using the Pythagorean theorem. So I'm going to pass out the worksheet. And that's it for this lesson.